My name is José Manuel Brotons Martínez. I'm from Miguel Hernández University in Spain, from Alicante. And I'm going to talk about the economic productivity of water in agriculture based on order-weighted average operators. Okay. Well, as you know, water is essential resource for agriculture, but there are regions or areas where the water is where you have a lot of water and you don't have to pay for water because you have the river and you have every water, every cubic meter of water that you want. But in other areas, it's very expensive. For example, where I live, where the place I live, we don't have water for water in the fields, and or if so, sometimes we have the water, but it's very expensive. But when we evaluate the productivity in the fields, you have to evaluate the productivity. But sometimes you need to evaluate the productivity of the water. So you need some methodology to compare the places where the water is very, you have a lot of water, with places where you have, or places where you don't have water. So that's why we propose this paper. So, for example, the indicators of water productivity are production per cubic meter, or income per cubic meter, income per euro of water. I think that one is the essential indicator. But there are many other indicators, for example, like the number of jobs per cubic meter, or well, several indicators. So, but the information is not always available because, as I was telling you before, it's impossible to compare the places where you don't have water with the places where you have a lot of water. So it's necessary to estimate the price of water for the places where you don't have water. Not only for make this comparison, but in the future, it's possible that we open more fields and we need more water. So we'll have to put a price of the water for the water, because if the water is free, at the end we won't have enough water for everybody. So many studies have talked about the evaluation of environmental assess, like contingent valuation method, or travel cost methodology, or hedonic prices. The first one, the contingent valuation method, is just inquiries, asking people what is he willing to pay for water, or for example, to visit or to preserve a natural place. Other methodology, for example, travel cost methodology, the price of a natural space is just obtained by the sum of the cost that we have to pay to be there. For example, if we want to go to a forest, we have to take the car, we have to pay the motorway, and we have to pay, for example, a fee to get inside. So the price of this space will be the sum of all the costs of all the people that go there. And the hedonic prices are just it's like the contingent valuation method, but if we have a place, we have a good, we have to have several characteristics of this good, and we have to assess each characteristics alone, and the price of the good will be the sum of all these characteristics. It's very difficult, or it's very price is very approximative, because sometimes the characteristics have a correlativity or are very related, so it's very difficult. In general, this methodology don't use or don't include the subjectivity. That's why we propose the use of fuzzy logic, and especially because we have to deal with lots of opinions, we propose the use of different aggregators. In general, the most common aggregator is just the average. We have, for example, 10 opinions. We have everyone has a weight of 1 divided by 10. But it's possible to have an aggregator, for example, at the average, a weighted average of it. So in this case, it's possible to assign the first expert, for example, 0.2, the second 0.1, and the third 0.3, and so on. But when we use OWA, the key is not the expert. The key is his opinion. So we assign, for example, 0.3 to the highest opinion, 0.2 to the second highest opinion, and 0.02 to the lowest opinion. It's like when we are watching, for example, Olympic Games, and we watch gymnastics. So the highest punctuation and the lowest punctuation are not considered. So the key here is just the opinion of the experts. We have there are many extensions. We have heavy OWAs, induced OWAs, probability OWAs, and induced probability OWAs, and many others. In general, the difference is just the first one is the OWA. The second, here the sum of the weights are equal to 1. In the second one, the heavy OWA, the sum of weights is not equal to 1. Sometimes it's interesting to have weights lower or higher than 1. The induced OWA here, the order is not based on the opinion of the experts. It's based according to another variable. For example, according to water, for example, it can be the number of hectares that a person has. So if you have more hectares to water, you have a better or higher weight. It's just an example. No? Probability OWAs consider not only an OWA, but also it considers the probability or the probability of an expert. For example, if we consider that an expert has very good information, so it's possible to consider a 30% or 40% of the result as according to the probability of this expert. And the induced POWA is just a combination between induced OWA and probability OWA. Okay, so the aim of this paper, of this presentation, is propose a new methodology for estimated economic productivity of water in agricultural companies. The price of the water will be estimated using willingness to pay or willingness to accept methodology. A reference price of production will be obtained using these aggregators. And finally, an application of the economic productivity of water in greenhouse paper plantation will be carried out. So first, we have the definition of the OWA. I don't want to put all the definitions. An OWA operator of dimension S is a mapping of OWA R and N to R with an associated weight vector of dimension N such that the sum of all the weights are equal to 1, and every weight has to be between 0 and 1 according to the following expression, where B is the jth largest element of the collection of A. Okay, there are many other definitions, but we can move on to the following step. So now we are going to estimate the water demand function for the places where we don't have water. Sorry, for places where we have water, but the water is free, and we want to be sure that the water we have enough water for the future. So first of all, we ask the people. Well, we are going to propose several prices, okay? And the people will have to answer with these linguistic labels. For example, totally disagree, strongly disagree, or totally agree. So we start with the price P1. For example, 0.2 euros per cubic meter. If the expert totally disagree, we stop here and the price will be 0. But if the expert, for example, agree or strongly agree, we register this information and we move on to the following price, for example, 0.4. And we ask the same to the experts. If he totally disagrees to pay 0.4, we stop. But if not, we move to the next one and so on till the last price. So the determination of the willing to pay from experts J will be the sum of all these membership functions multiplied by each price. Well, for the price of the first one, for the difference between the price of the second minus the price of the first, the third opinion multiplied by the difference between the P3 minus P2, and so on. After that, we will have to assign or obtain weights for each methodology. These weights will be obtained according to experience. Okay. And finally, it will be possible to obtain the water demand function as with the sum of the willingness to pay prices. Adding the weighting, the weights of the prices, the willing to pay prices higher than the proposed price. For example, for P 0.2 will be the sum of all the weights of the willingness to pay higher than 0.2. Okay. We will do the same for the water supply function, but in this case we start with the higher price, and the willingness to accept will be obtained from the maximum price and subtracting the membership function of each lower price. And the equilibrium price will be obtained. Well, we have two lines. One will be the demand function, another the supply function, and just interpolating the value. This is very easy, and we have no problem with this. Once we have the willingness to pay price, we now propose some indicators to get the water economic productivity. So the water productivity will be the quotient between the value of the production, for example, the number of kilos multiplied by its price, divided by the cost of the water, for example, the number of cubic meters multiplied by its price. And here, well, this, well, at the beginning of the year, we don't know the price of this year. It's possible to know the historical prices for the water or the historical prices for the production, but we don't have the price of this year. So we only, well, we don't have, well, the only thing that we have is historical prices. So it's possible to get an average of these prices, but sometimes the experts know that this year is a very bad year for production, so the prices will be goes up, or it will be a very good of production. We have many productions, so the prices will go down, and the same for water. So we need to get an average, but considering these circumstances. So the use of OWASP, I think, will be very interesting, because the OWASP allow us to get values higher than the average or lower than the average, according to the experience or according to the opinions of the experts. So to get this water productivity, it's possible to involve it's possible to get this dividing ANOVA obtained from the prices of the productivity of the prices of for example, in this case of the paper, divided by the ANOVAs of the prices of the water. Okay, because the equation between V and W will be always the same. No? We have no problem with this. So we propose the use of the OWA economic productivity water, and in the same way the heavy OWA economic productivity water, just considering that the sum of the weights is not equal to 1, is between 1 and n. The use of induced OWA or the weighted average economic water productivity, just considering another variable, for example, the number of hectares or his expertise or his position in the company, and the probability and the POA EPW, the POA EPW. Okay, the definitions are very similar. So once we have this, we propose the big application. We have choose 1 hectare of Danubio peppers. It's a variety of peppers under greenhouse in 2021. The average production for a greenhouse of peppers of 1 hectare is 35,000 kilos per hectare, and the water consumption is 8,200 cubic meters. And we wanted to know the economic productivity of the water. So experts were asked for their willingness to pay and to accept. Here we can have the main weights for the OWA. For the heavy OWA, the sum of these weights is not equal to 1. This is the induced variable. In this case, is the number of hectares and the spares and its probability. Okay, these weights are related just to opinions, and the probability is related to the expert. Okay, and the same for the supply, because 6 experts were considered about the possibility of, for example, it's basically the government of the community, where you have the water, but what prices would you consider will be enough to have water in a very good condition and a very good quality in the future? Okay, so this is the probability of the spares, the induced variable, the heavy OWA, and the OWA. So this is the answer. So for example, spare 1, he considered that the best price for the water would be 0. He wants water but free. The second one is willing to pay 0.05 euros per cubic meter, 0.10, strongly agree to pay 0.6, agree 0.6, 0.8, 0.6, and strongly disagree 0.2, and totally disagree 0.3, and so on. No? The same for the supply function. So according to this, it's possible to get these two, the demand function and the supply function. Okay, it's obvious that everybody wants water free, and nobody wants to pay water with a high price, because 0.35 euros per cubic meter in Spain is very, very expensive. And everybody, nobody wants to offer free water, but everybody wants to offer water with high prices. So each methodology gives us different membership function for each price. Okay. Well, I think it's interesting to get all this possibility, because it's possible to select every year according to what we expect to have in the future. No, it's possible to combine historical information with future information, but there are many intersections. So in the future we will deal with too many intersections in order to get how to deal with it, no? Because we have to consider all the possibilities. And here, the same, we have the annual prices for peppers, okay, and prices, and this is the OWA, the heavy OWA, the induced variable, the spares, and the probability. The probability here is considering the position of the spares in the company. For example, if the spares is in the marketing company, in the marketing department, for example, it's possible to consider a very high mark. But if he, for example, is, I don't know, he's just traveling in the assembly line, he has a very low mark. It depends, no? And finally, it's possible to get the value of the water price according to all these indicators, the pepper price and the productivity. we want to point out that the water price will change from 0.14 to 0.26. The paper price from 0.77 to 0.84, and the productivity changed from 12 to 25. So it depends on the aggregator that we use. So we get a huge range of possibilities. And that's all. This is the conclusion. The aim of this paper is to introduce an information in the traditional calculation of the economic productivity of water using several indicators. These operators provide new ways of aggregating prices and express opinions. This makes it possible to visualize the potential risk of certain crops not becoming profitable because it takes many years at exiguous prices. And this form of aggregation allows for simplification if circumstances change. And the result of our empirical applications show that productivity can almost double depending on the aggregator use. The results of the big application show a rise of productivity values from 12 to 23. And that's all. Thank you very much. You have any questions?
Could you go back 2 slides?
Yes. Well, I'm not sure, but I will try. Here?
No. One more. The other direction, to the end.
Oh, sorry. More?
Yes, one more. One more.
What?
Yes, this one.
Okay.
In my opinion, I can't see a correlation between water price and pepper price. But maybe we have a correlation between the water price and the productivity. How?
Correlation between what?
The correlation.
Correlation, yes.
Yeah.
Between
Water and pepper price.
Okay.
I don't see any correlation.
Not especially. No. Well, not because the price of the pepper. In this area, the pepper is exported to, for example, to the Netherlands or exported to Europe. So the price of the pepper is not well. If the market will be a local market, if we have a very good a negative correlation. But if the pepper is exported to Europe, we have to compete with other areas if we have not lot of water. So I think there is no correlation.
Okay. Maybe you have a chance to have more reliable pepper price, which you can create a correlation to the water price.
Well, I think it's a nice idea. Yes, I think it's a nice idea.
Because
yeah, but the problem is that well, we have every year or every single week we have the prices of pepper, but the prices of water is, for example, some areas we have to pay for water, but you have to pay the same price every year. So, for example, this year is a bad year in Spain because we have a drought. We don't have water, so the price is very high. So the solution is not to farm peppers because we don't have water. But I'm sure that people from other countries will come from Europe to cover this problem. But it will be a very good idea. But the price of the water is very I don't know the word in English, but it's very stable. So this is the problem.
okay.
Okay.
And you find this method in Spain already applied?
Yes, we are working in Murcia, in Emida, with people that have greenhouses and they are trying new methodology, for example, new covers or new plants or new varieties, and we have to work with water productivity, with social productivity, and we implement this methodology not only to get the productivity, but in order to assess all other resource or all the information that we need from the field. Thank you.